Everybody ready? All right, so first off, I'd like to thank everybody for letting me come out here and talk to you tonight. And my name is Yoder, and I'm going to be talking about my journey with continuous deployment, and specifically with GoCD. Before I start, I'd like to thank again Billy, who is actually my boss, and him coming out and videoing me and doing the sound work is really awesome, and Sam for working with me on times, dates, etc. So this starts with me, of course. What is it about me that makes me qualified to talk about this at all? So I've been working 15 years in IT, and I started out at help desk, and I did sysadmin, and I actually came off a really cool job working with Chef. I was having a lot of fun doing that for about 5 years. And then I get this call to come work for this DARPA project. And yeah, guys, it's DARPA's, you've heard about it. And so they came in and said, okay, you know Chef, right? Well, guess what? We're going to have you work on continuous deployment. I'm like, how does that go? Okay. So what we actually did, it wasn't just me. It was a group of 5 or 6 people on this project, and none of us had any experience with CI, CD, continuous deployment, continuous integration, continuous delivery. We didn't know what that was. That's something those big companies do. And so we all got together, and we're sitting down, and we're like, okay, how do we do this? We bought the continuous deployment book, continuous delivery book by, what's his name? Jez Humble, that's right. And we bought this, and we kept hearing, oh, Jenkins. Everyone's using Jenkins. We're like, okay. Who are we to say anything else? We don't know anything about it. All right, Jenkins it is. So that's what we did. We deployed Jenkins, and we started using it for a while for a project. And what we found is that Jenkins is actually a really awesome CI tool. So CI is like continuous integration, right? So for me, what that means is you check in your code over here, and then you run a test every time you check it in. It's like, okay, that one's good. That's really good. So you can use that. Now, what happens beyond that? You don't just want to test once. You actually want to recombine these. Maybe you want to run an integration test. Jenkins can do it, all right. It does have jobs that you can string together with, children, and you can inherit artifacts and start up a build this way. But we started finding some limitations when we did this. So for one, Jenkins is built more with these one test per repository model. And we found it a little bit hard to visualize what was happening when we'd string things together. There are plugins. There's one called the Build Pipelines plugin, which would let you visualize a little bit. But what we found is we wanted to do more of a build tree. So we wanted like this and this combining over here and combining again, and it all kind of looked like a tree structure. And there was no visualization tool for that, so we didn't really know what was going on. It's like, we think it's working. We can't really see what's coming out. We can go look at it, but not really any good visualization. But that wasn't actually the worst problem. The worst problem we had was that we had this kind of uneasy feeling that, okay, if I push in a piece of code, what's to prevent this from building here and then something else coming in at the same time, and then they combine in unexpected ways? And so this was a consistency problem. And it actually turns out, I didn't know this until I switched to the thing I'm really talking about tonight, is that there's this diamond dependency concept. So what does that mean? That means this is actually inherited from a C coding world here. This is a diagram of diamond dependency with a class, subclasses, and then they subclass again. And it turns out that when you push something in over here and push something in over here, you kind of get unexpected results when they're recombined, and that is the cause of a little bit of unpredictability. And this concept translates directly into build trees. When you're trying to build and recombine things, well, if I start my build over here, starts checking over here, and oh, by the way, I'm going to push a piece of code over here, and now I've got some sort of weird undefined build state. Like, oh, does it work? Well, we think so. That's not really good enough. So that was this race condition problem. So, as it often goes in DARPA projects, we had a throw everything away and start over moment, which can be awesome, which it was in this case, because one of my friends at work, name is Mike, had found this tool, which has just recently been open sourced, called GoCD. And just to give you a bit of background on what GoCD, where it came from, the company that makes it is called ThoughtWorks, and I notice they're actually going to be coming in and talking, so it'd be interesting to see what they have to say about this. ThoughtWorks is a CD consulting company, and GoCD, in its earlier incarnation, I believe was called Cruise Control, and Cruise Control was their system for putting things together and doing CD. Since they're a CD consulting tool, this was their, or CD consulting company, this was their tool that they used, and they sold access to it. And then they ended up open sourcing it for us, or not for us, open sourcing it, which is really convenient for us, because that was right about when we did this project reboot. So if you're interested, I've included the ThoughtWorks, the GoCD URLs, and it's actually an open source project that's on GitHub, so you can do pull requests, and that's pretty cool. And now, what I would actually like to do is show you a demo of GoCD in action. And ThoughtWorks very kindly provides this VirtualBox Vagrant-based solution. You don't even have to do anything. I did no modification beyond these shell commands up here to prepare this demo. So if you wanted to, you could right now pound the heck out of their wireless, pull down a big Vagrant image, and start it up. So I will go do that. All right, so you see I've done all these steps up here, the Vagrant steps, etc. And all that's left is for me to git push local master. So I'm doing this on this VM, which is straight on my machine.
Can you please control+?
Oh. All right. Here we go.
Thank you.
Sure. So this is actually running, I've got this Vagrant VM running right now on my box, and GoCD server is running in it, and it's got local git repo, which I'm pushing to. All right, so it started. Well, that's great. Hey, cool, end of demo, right? No, not quite. So I've got it running in my box here, and what's going to happen is that commit is going to fire off this pipeline right here. And you notice nothing's happened yet. And that's because it's a little bit slow. When I run this whole delivery stream, it takes about 10 minutes. So I'm not going to make you sit there waiting for 10 minutes. I've created this small little time lapse of me doing just that. So you see my git push, and you see there it kicks off that pipeline. So that's an opportunity for me to show you some things about GoCD. This up here, these big squares are called pipelines, and that's like the basic unit, kind of analogous to Jenkins jobs. And underneath it, they have stages, and you can break up your testing in this way. All right, so it's running its stages, it finished, and then, oops, two things happen at once. Now I wonder why that is. Let's go back and look at the GoCD interface. If I look at this one build right here, which just got kicked off, this stream which just got kicked off, shows me this nice nifty little UI with the stream. So this is the value stream map, which is a pretty critical feature of GoCD. This is, for me, this value stream is what sets it apart from a tool like Jenkins. It's the ability to show the whole stream at one go and see the linkages here. So actually, I'm going to click this little pin. You can see that this is the parent of 3 pipelines, but it's also the grandparent of this pipeline, which is important, and I'll show you why. All right, so you notice that the children kicked off immediately, but the grandchild did not. And another thing that's happening is these two are building kind of interleaved. If you watch, it says, okay, First one, second one. See how they're kind of switching back and forth? And that is because we have one agent running. This particular demo has a single agent running. So it can only execute one job at a time. And there's some implications to the way you could do parallelism, which I'll get into a little bit later. All right, so those are done. It kicks off that grandchild I showed you, which is this guy right here. And so this is that critical little piece of fan out, fan in. See, it fanned out with these two, but it didn't fan in here until these are done. So this is that really important piece of GoCD, which is doing the heavy lifting of ensuring consistency for you. It will not build this because it knows that these are parents. It's going to make sure that these build first, and then it's going to build this one. All right, so it finishes that middle one, and then it kicks off these three all at once. Again, if you look at the value stream, what's happening? These three are all downstream. They can all kick off at the same time. So I'm going to let this process run in the background. It'll take about 10 minutes, and we'll come back to it. All right, so I did mention this value stream, right? And why it's such an important part of GoCD. So for me, this is the most important thing. When you first start using GoCD, you'll install a few things and you'll see your pipelines executing, and there's nothing really differentiating it from something like Jenkins or Bamboo. But once you start linking them together, you start creating that value stream. And what does that value stream give you exactly? Well, kind of the way I was showing there, you start seeing this map. You start being able to see this thing together with this thing, together with these three things, made up this build. And you can see exact Git commits by someone at a certain time, and you can see past streams. And you can watch your product kind of growing over time or changing. And it gives you a lot of visibility into who's doing what. All right, so when we were looking at those pipelines, I showed you the top level. There's actually several levels below this. There's a top level. This can be a little bit confusing. It was for me when we first started. Like, we installed GoCD. I'm like, okay, what am I supposed to do here? There's a lot of levels of things to do. So the top level is those pipelines I showed you, those big squares. And those can execute in parallel, as you saw. So that's kind of analogous to the Jenkins jobs, which do the same thing. So if you're used to Jenkins, think of them as jobs. But it's confusing because GoCD also has jobs. So we'll talk about those in a little bit. Below them is the level of stages. These are those little green bars and red if things go wrong. So you'll see those going, and we saw them interpolating. So there's a kind of funky thing you have to be aware of when you first install GoCD and you start using it. We're running with one agent. So all of those stages are always running on the same agent. But that doesn't have to be the case. Little story, when we first started adding agents, because you want to add agents to do parallelization, you don't want to just like have everything wait for one agent to execute. When we first added the agent, we started finding that our stages were breaking. And why is that exactly? All right, so the reason is because the stages can execute on different agents. So if you're running on one agent, stage 1 executes, agent 1. Stage 2 executes, agent 1. Stage 3 executes, agent 1. So if I've created state in there somewhere, so for instance, anybody here use Python? Virtual envs.
Yeah.
Okay, nobody else does. So I'm going to have to explain on that a little bit.
For the rest of you.
So virtual envs in Python are, kind of think of them as a collection of libraries, little self-contained collection of binaries and libraries, and maybe you want your Python to run a test for you. And so you set up this virtual env for you to do it. Well, guess what? If that started in stage 1 and then your second stage ran on agent 2, that virtual env is not going to be there. Oops, what just happened? Bad things. So that's something to be aware of, and you can work around that by either using the artifacts. You can publish an artifact and pull it back down, but sometimes that's a bit cumbersome for big things. So I'll get into something I want about that later. or you can just start collapsing your stages together. So one of those solutions may work for you. Below stages, you also have the concept of jobs, and jobs are run in parallel. We don't use these very frequently. What I recommend is if you don't have a need to run basically threaded jobs, you just do one job per stage. And below that is tasks. And tasks are also running serially. So that would be a collection of like test commands. Like you might say, you know, my test app -a -b, you know, whatever. That's going to be at that level. So one of the interesting things about this fan out, fan in, diamond fanciness is that it's actually not terribly apparent when something's blocked. So we have had it happen when developers come to me and they're like, hey, my stuff just passed, but downstream, like in that stream I was showing you, you saw the green here, the next pipeline, nothing's happening. What happened? So because of the fan out and fan in, it is possible, and in fact desirable, once you're here and you fan out and you've got these two pieces here, this one passes, downstream of it won't build yet. Why is that? Because the sibling has not passed yet. So that can be kind of annoying if you're just sitting here waiting for this guy, but it's a good thing. Like you wouldn't want this other one to build yet, because this one might be failed, it might be paused. So you can pause pipelines, of course. So that is a little bit of a failing of the UI, in my opinion, that you can't look that up directly, but it's something to be aware of. Me as the CD guy, I have to sometimes go and investigate these things, like, okay, what happened here? And the cleanest way is to make sure everything's building all the time. All right, so that's about the siblings, etc. There's another thing you could do in GoCD. Actually, let me go and check the status of the demo. All right, here was our value stream before. What's it doing? Yay, it's done. So what does this mean? It means I can go back here and say, okay, this guy had what going into it? Look at these. These are Git repos, including this one. Here's that commit I did, is going in and reusing commits that have passed previously. So I've got one in, and it's being used against previous builds that worked. And not only can I look at this build, I can look at previous builds. I can see what triggered them. And there's also an interesting thing you can do. This guy is an intermediary pipeline. This was in the middle. When we looked at you can look at the perspective from any pipeline along the way. So I was showing you the originating pipeline where I did the git commit. This is one of the intermediary ones. So I can see what went into it at what times. You can look at it from any perspective. So if I look at this pipeline has actually two materials. So in GoCD, you can say, all right, I want to have a git input, so test when you see git changes, and also test when you see pipeline changes. So in this particular case, this has both. So if I look at the value stream for this build, I go upstream a little bit. So I'm clicking around a little bit. So if you guys want more information at the end, I'll definitely tell you. But here's another part of this UI. It's very important that you be able to see this. And if you don't have a dedicated UI, you're never going to. Is I can see that this actually triggered 2 builds. And I can see that this one triggered 3, and one of them actually failed. So then I can go and investigate if I need to. I can go and do some archaeology. All right, so back to some of the things I've learned and done with GoCD. So with this big value stream, what you can do is, I'm at the end here, right? I want to include an artifact from something that's way over at the beginning. Let's say I've got a really complex build tree, which we do where I work. We've got about 40 pipelines and 40 Git repositories. I could, at the end, say, okay, I want to reach back generation 1, 2, 3, 4, 5, 6, generation n. I could go back that far and pull an artifact from all the way at the beginning and reuse it at the end. That sounds pretty awesome, and I'm glad I can do that, but it has some implications. When you do this, you've made this connection across these different pipelines, and it ends up locking them. So I can't change these. I can't change the relationship anymore between them. Okay, maybe that's okay. But what if I want to do some refactoring? It kind of makes things harder to change. So I'm not saying you shouldn't do this. Just be aware of the consequences. And the other problem with doing this is that the UI is kind of so-so. So you get a text box defining these relationships with slashes for every generation. So you can imagine a huge drop-down with lots of weird relationships that are not really apparent. What I would like them to do is make a nice GUI where you can drag things around, but whatever. All right, so what we do for building our tests, our architecture is actually also using Docker. And the way we run Docker is in clusters. Our product is delivered continuously on a target box with running Docker and about 10 or 15 clustered Docker containers. And we make use of GoCD, make use of interesting features to propagate our builds upward. The way we do this is, our Docker clusters are configured with this kind of configuration system called HCL files. HCL is HashiCorp language, I think. And you use these, you say, okay, I want a Docker container, and it should run with this tag, and these ports, and blah, blah, blah. So what we can do is use the fan-in feature of GoCD and say, okay, this pipeline over here created a Docker container, uploaded it to our private Docker registry. And also, it publishes its HCL file. This other one is also doing that. So together, they make an integration test. That integration test has automatically inherited 2 HCL files. And I can tell it, run this cluster with these 2 that it inherited, and do a test against it. And that integration test can run with another integration test. The HCL files start accumulating. And because of the way GoCD is locking down the versions, I can say these HCL files are at 1.2.3, 1.3.4, etc. Stick them together, and at the end, we get a giant cluster of very, very predictable versions, seeing how everything works together. So that architecture works really well for us. Another cool thing you can do with GoCD is the configuration file is a XML format. Great, right? But it's also in a Git repository. And this is actually the way GoCD is managing its changes. So when you log into GoCD and you make a change, you'll see a Git commit each time. And a cool thing you can do with this is you add a Git remote on there, and you push to it every hour. Does anyone know what I'm talking about with Git remotes? Yeah? Okay. So it's basically you're copying the changes as they're made up to a remote machine. So that means you have an up-to-date version of your XML file, which means you can do things like, well, where are all our HCL files? Let's go investigate the XML file. And then one of our guys on the project, his name is Scott, he made a parser which does this for us and writes it to our wiki. So now we know where everything is. I think that's pretty awesome. All right, so now it comes time for me to complain to you all. All right, so some of the things are, I mentioned not being able to see what's blocking and what's blocked. Yeah, that's kind of a problem. So what I would really like to see, GoCD has all these awesome APIs for interrogating it or even configuring it just using REST calls. It'd be pretty awesome if I could see something which goes and figures out what's blocking, what code is being blocked, where it's blocking, what pipelines, etc. I would love to see that. Another thing is that whole question about the agents changing and you losing all your state. There is a discussion online about these called sticky agents, and that would get rid of this problem, which would be nice. And finally, there is a problem when you load up a very big configuration file, It takes a long time to edit. This is a known problem, and that would be pretty awesome. So yeah, I'd like a pony. The awesome thing about this is it is an open source project, so it would be possible if we could dedicate resources to it, or anybody. If you're using this, of course, you can go and be like, I want this. I'm going to code it, and I'm going to do a pull request. Everybody knows how GitHub works, right? Public coding at its finest. All right, so if any of this sounds really cool to you, as cool to you as it is for me to work on, I would definitely encourage you to contact me and come work with me. That is my email address, and you can get to me on LinkedIn or GitHub. I would encourage you to contact me, please. And thank you for listening, and I hope you learned something about GoCD today.